So with these functions, what we have to remember when we're solving trig functions is we don't want to look at this and go, oh, I'm just going to divide by something to get rid of it, because we remember that tangent of x, so tangent can also be defined as sine of x over cosine of x, and that equals 3 sine of x. And there's a part of us that kind of wants to divide both sides by sine of x to get rid of it. But if I do that, I'm actually eliminating a function, which means I'm losing answers. They disappear, they go away, but there actually are answers as part of that. So instead, what we are always trying to remember to do is say, okay, I am going to instead set it equal to 0, much like we did back when we had all of our quadratics. So to set that equal to 0, I'm going to go ahead and then subtract, and I'll have negative 3 sine of x minus sine x over cosine x equals 0. And then like we've been doing, like we looked at with quadratics and other things, but I mean really any kind of a polynomial is, can I factor anything out of what's going on? And the answer is yes, I can. I can factor a negative sine of x out. Why do I do negative sine of x? Only because I like my leading coefficient to be positive. So I'll have plus 3, and then it'll be plus 1 over cosine of x equals 0. And now I go, oh yeah, I have two things that are being multiplied. When is this 0? And then when is this 0? So I go, all right, negative sine of x equals 0. Inverse sine, you can do that, but I'm going to always refer you back to our trusty unit circle. That's the ugliest unit circle available. But and I wonder, when is sine of x 0? Or when is negative sine of x 0? Sine is 0 at 0 and pi. So when is negative sine of x 0? At negative. So it's the same thing there. So I have, or I could, if you want to, if I multiply both sides by negative 1, I get sine of x equals, 0. You could call it negative 0, but that would actually be wrong. Sine is sineless. 0 is sineless, I mean. So x equals 0 and pi and 2 pi, because I said I'm on this interval. Then I'm going to solve when is 3 plus 1 over cosine of x equal to 0. So I'm going to have 1 over cosine x equals negative 3. Cosine of x is equal to negative 1/3. And then I wonder, and looking at my unit circle, where is cosine negative? So cosine, remember, is always referring to, in my unit circle, cosine is the x-coordinate. Where is where is the x-coordinate negative? It's in these two quadrants. All right, negative 1/3 will be, somewhere right about here, if this is negative 1. So that means this angle and this angle are my two angles as I go around my unit circle. And there isn't a handy-dandy unit circle value that gives me negative 1/3. I mean, yes, we'll get negative 1/2. That happens. We'll get square root of 3 over 2. That happens. We're going to get lots of different things. But in this case, then you're going to want to probably run it through your calculator, do inverse cosine to find. And your calculator will give you one answer to this one. You have to be smarter than your calculator to get the second one as we go around the circle. So we would have these 3 answers for sine, and then these 2 answers for cosine. Occasionally, you just got to pay attention. They might, up here, and I just erased it, I don't know if you saw it, they'll say from 0 up to, but not including 2 pi, in which case I wouldn't include 2 pi a second time. And the reason why they would do this is once I've done one rotation, I've gone all the way around and almost up to 2 pi, but since 2 pi and 0 are the same, we wouldn't include it and do it twice. So just pay attention on problems to know which interval we're working on. All right, I just answered offered up questions here. So I screwed up because this sine cosine x is positive. This was positive. I moved this over to that side, which is negative 3 sine x. This should be positive, which means this is positive, which means this is negative, which means this is positive, and this is positive, which means I'll be in the first and fourth quadrants, not here and not there. Sorry about that. All right, then this ball of joy here. We get started and people look at these and like, what do I do? Oftentimes a helpful thing is to just convert it into cosines and sines and work your way through it that way. So if I do that, I have 4 over, and secant squared is 1 over sine. So this would be 1 over sine squared t. Don't worry, we'll reduce that complex fraction in a second. Plus 3, this is already a cosine t. And this equals 2, and cotangent is cosine t over sine t. And then tangent is sine t over cosine t. Now where I said be careful in the past, don't divide things away. Here we're multiplying inverses, so they will multiply to 1, leaving me just with 2. And then I'm going to move that over. And I did this incorrectly already. I already see that. Sorry about that. It's cosine. I make the mistake that I was going to tell you out loud while I was drawing it, not to make this particular mistake. And then in my process, made the exact mistake I was going to tell you not to do, which is secant is 1 over cosine. Cosecant is 1 over sine. And it would have been nice if they would have named the cos together, cosine, cosecant, but they're not. All right. So to simplify this fraction, dividing by a fraction is multiplying by its reciprocal. So I end up with 4 cosine squared t plus 3 cosine t minus 2 equals 0 because this was 1. So I'm going to just subtract the 2 over. Hey, it's a quadratic, but we can't factor it. If we can't factor it, then we're going to use, that's right, folks, the quadratic formula. Now you might think, oh no. But remember, when we did the quadratic formula, what did it start? It started with x equals something. Well, in this case, it's not x, it's cosine of t equals negative b, negative 3, plus or minus the square root of b squared, which is 3, which is 9, minus 4 times a times c, 4 times negative 2, all over 2 times 4. Negative 3 plus or minus the square root of 4 times 4, that's 16 times 2 is 32, positive 41 over 8. So there's my 2 numbers. And then I need to run them through my calculator. So I get my 2 values. And I'll have cosine of t will equal one of 2 numbers. So running it through my calculator, these are my 2 values that I get. And automatically I know that one of them is an extraneous solution because cosine will never be over 1. Which means this is not possible. So then I take inverse cosine of both sides to find out what t will work for that equation, which I'm not going to do. You can run that through your calculator on your own. All right, so then with this, we have lots of varieties of identities that we have to eventually figure out and know. And ultimately, memorizing them would be great. But there's just a lot going through. Some you'll be expected to know, like my Pythagorean identities. So sine squared plus cosine squared is 1. Here's another one. If you're wondering, 1 plus cotangent squared is equal to cosecant squared. Because if we run this back through sines and cosines, it will be the exact same place. And if you're wondering, all this is right out of your book in the section that we're working on too. They have this chunk of info and this chunk of info. And sorry, I took a picture with my mouse in the way. But here's my other Pythagorean identity. And then these are difference of angles. If we had time, which we didn't in class, I was going to prove a couple for you so you could see it. But if I have a number like cosine of 75, I can use this idea to find the exact value of cosine of 75, because 75 would be the sum of 2 angles, 30 plus 45. So if I did that, I would get cosine of 30 times cosine of 45 minus, and again, I'm using this formula right here for adding, minus sine of 30 times sine of 45. And then you'll go, okay, cosine of 30 degrees is the square root of 3 over 2. Cosine of 45 is the square root of 2 over 2. Sine of 30 degrees is a half. Sine of 45 is square root of 2 over 2. So I'll have square root of 6 over 4 minus square root of 2 over 4, which will then just be the square root of 6 minus the square root of 2 all over 4. And that's the exact value for cosine of 75. And you might think, why would I ever care about that? You might not, but it's procedurally working you through things because it gets more complicated, because then instead of having necessarily numbers there, we'll start throwing variables in and then solving for things and finding angles, etc., etc. The last thing down here, which says lastly, if I want to rewrite some number sine of bx, so b could be 2, like if I had 3 sine of 2x plus 5 cosine of 2x, I can rewrite it just as a sine function. All right, so I can change this sine and cosine and write only as a sine function, because, again, if you think about it graphically, a sine wave and a cosine wave are very similar. One is just phase shifted pi halves to the left or pi halves to the right, depends on how you want to think about it. But here's what you would do with the a. You say, well, where is the a? We're actually finding an a. This was my original equation. So a squared is m squared plus n squared. This squared plus that squared is a squared. And then cosine of c is m over a, sine of c is... And you could put it all together to get this equation, which I think is maybe one of the questions on the check your understanding problems. It's time for us to get ready to go. So as always, paying attention, doing all the check your understanding problems, because like I said, if you did them, you actually saw maybe something like there appear on an exam, not uncommon.